Okay, hopefully at this stage you're after maybe, I don't know, something maybe is after got off in your brain. You're thinking there must be something to do with this unit circle we were dealing with the cast and the waves, okay, the trigonometric waves. But if not, don't worry, okay, hopefully it'll make a bit of sense here. Right, if you look to the left of your screen, you'll see the unit circle, okay, and at the top you'll see sine, cos and tan in green, blue and grey. Let's say I put this angle up to 120. Okay, so the angle's at 120. The sine of 120 is 0.86. Cos of 120 is minus 0.5. And the tan of 120 is minus 1.732. Okay, problem so far. Let's just concentrate on that though. And we'll focus in on the cos of 120. Okay, so the cos of 120 was 0.5. Okay, so focus in on that. Cos of 120 is minus 0.5. So cos of 120 minus 0.5. Right. So here it is, minus 0.5. Now look to the right side. 120 is here. That's why that black line is there. Have a look where it crosses the cos line, which is the blue line. See that blue line there? Okay, that curve. Have a look where this crosses it. It's at 0.5. There's 0. There's minus 1. There's 1. So it crosses it at 0.5. Let's have a look at the sine 120. That's the green. Sine 120 is 0.86. Let's have a look where this line at 120 degrees crosses the green line. Here. It's nearly 1. It's 0.86. Look at the tan. Have a look. Sorry, the tan of 120 is minus 1.732. Have a look where this line at 120 crosses the tan. Minus 1.732. Okay, so that's how both the unit circle and the sine, cos and tan waves link up. Okay, they really are just different pictures of the same thing. Okay, bear with me now for a second. If I drew another triangle here, straight down to 240, and there, do you think that the cos of that would also be minus 0.5 again? It sure would. Okay, it definitely would. That's 240. Okay, so 240 degrees is here. If I drew a line down at 240 degrees, look where it would hit. 0.25 again. Okay, that's why, remember in all those questions we were doing earlier on with the unit circle, we were generally getting two answers. That's why. Okay, right, I'm going to look at it from a different point of view now. I'm going to say cos theta is minus 0.5. I want to find out what theta is in degrees. Okay, so how to do that? I would go to minus 0.5, minus 0.5 here, okay, on the y-axis, that's minus 0.5. I would draw a line across, it would hit it here, so it would hit it at 120 degrees, so 120 degrees, and it also hit it here at 240 degrees. However, if I kept the line going across, do you think it would hit it again and again? Because remember, this wave keeps going on. Okay, so just like here, I went at minus 0.5, it would hit it here, which was the 120, We also hit it here at the 240, but look, it would hit it again, and again, and again, and again. Likewise, if we look at this unit circle, I will get cos minus 0.5 here, and here we said already. So if I go from here, so the positive x-axis, if I measure from there to 120, I'll get minus 0.5. If I keep going to 240, I'll also get minus 0.5. However, if I keep going around again, so another 360 degrees, so that will be 120 plus another 360 degrees. So if I went around 480 degrees, I'd also get to minus 0.5. And if I got to here again, which would be 240 plus 360, which would be 600 degrees, I'd also get minus 0.25. And again, if I went around another 360 to here, and here, and then here, okay, I would get 0.25 again and again and again, which brings us on to a thing called general solutions, okay, which we'll do now in a minute. And it's very easy to get the general solution of something. You just add 360 the whole time, okay, just like I'm doing here. I have 120 and 240, I add 360. 120 I get 480, and then I add 360 to the 240 and I get 600, and I keep going, add 360 again to the 480, which would be 840, and so on and so on, okay? And likewise here, if it crosses here at 120 and crosses again at 240, well, if I add 360 to 120, that will actually bring me to here, which is 480, and if I add 360 to 240, it'll bring me to 600, which is here, 600 degrees. And if I add another 360, I will actually keep getting these piles. Okay, so if they asked us to find the solution, not the general solution, the solution to cos theta equals minus root 3 over 2, here's how we do it. We have our unit circle, we have our cast, we find out what minus root 3 over 2 is in our logbooks, and we get 30 degrees. But remember, we look, see what sign it is, it's minus. So it's cos, it's 30 degrees, and it's minus. So we have to look for quadrants that cos will be minus. So it's the S quadrant and the T quadrant. We measure then from this line, so it'll be 30 degrees this way, 30 degrees this way. So our answers then will be measuring from the positive x-axis, which is here. We measure all the way to here, it'll be 180 minus the 30 degrees, which is 150 degrees, and our we go with orange from here past the 180 degrees and adding on 30, so 180 plus 30, which is 210 degrees. Okay, so there's our two answers. However, we're asked for the general solution. So the general solution, very, very easy. There's just an extra bit we have to do. Okay. So we have 150 and we have 210. Right. There's the first answer. Then we'll add on 360. So 150 degrees plus 360 is 510 degrees, plus 360 is 570 degrees. Add on another 360 and we get 870 degrees, another 360, we get 930 degrees, and so on and so on. Okay. Here's how we actually write it. Okay, but that's the method behind it, but here's how we write it. Okay, we say general solution is, and what we say is 360 degrees n plus 150 degrees, or 360 degrees n plus 210 degrees. Now that will give us every solution, because if we put in 0 for n here, okay, so 360 multiplied by n, which is 0, plus 150, we get 150, and likewise we'll get over here 210. However, if we put in 1 for n, well, that'll be 360 multiplied by 1, which is 360, plus the 150, which will give us the 510, and so on. We can put in 2 for n, and 3 for n, and 4 for n, and so on. That's if we're dealing in degrees. They could ask us to deal in radians. Very similar. Okay, let's say I checked out what minus root 3 over 2 was in radians, and that would be pi over 6. Okay, so I'll just redo this. Right, so this here would be pi over 6, and this here would be pi over 6. And remember, from here all the way to here is pi radians. So that means from here to here, rather than 180 degrees minus 30, it would be pi radians minus pi over 6 radians, which would give us, instead of 150 degrees, it would give me 5 pi over 6 radians. And likewise down here would be pi plus pi over 6, which would be 7 pi over 6 radians. Okay, and then 360 degrees in radians equals 2 pi radians. So instead of saying 360 degrees n, we'll say 2 pi n plus 5 pi over 6, or 2 pi n plus 7 pi over 6 radians. Okay, last one then. It says find the general solution to sine 3 theta equals a half. Okay, so what that means is, rather than our range being between 1 and minus 1, it'll be between 3 and minus, sorry, wrong there. Rather than our period going from over 360 degrees, it'll be divided by 3, so it'll be 120 degrees. Okay, that's the only difference. You don't actually need to know that. Okay, this is the method we use. Same as the last one, really. Sine 3 pi equals a half. Okay, we'll do it in radians. So the sine of a half is pi over 6. Okay, and it is positive, and it's sine. So we've sine pi over 6 a half. I'll just sketch my unit circle. C-A-S-T. Pi over 6. We're looking for where sine is positive. Sine is positive here and here. Pi over 6, which is 30 degrees, just to give you an impression of what it is, how big it is. So that will be here and here. So pi over 6, pi over 6. So if we're starting on the positive x-axis and we're measuring to here, we get pi over 6. Or if we go from here to here, it'll be pi minus pi over 6, which is 5 pi over 6. Okay. So no difference so far. So this 3 hasn't made any inroads. This is the only thing we change. So we say sine 3 theta equals 2 n pi, or 2 pi n, whichever you want, plus 6. Actually, I'll just give myself a bit of room here. Okay. Just start over here. Sorry, now. Sine 3 theta equals 2 pi n plus pi over 6, or 2 pi n plus 5 pi over 6. Okay, remember, we want to find out what theta is, not what 3 theta is. So we just divide by 3 the whole way across. Divide by 3 here, we get theta. Divide by 3 here, we get 2 pi n over 3 plus, it'll be pi over 18, and then r 2 pi n over 3 plus 5 pi over 18. And there we have it. Okay, so there's no huge difference really when we have a number in front of theta, bar when we get to the very last section here. Okay, we let 3 theta equal what we got, and then we divide by 3 the whole way across. Okay, hope that makes sense, guys. Okay, thank you.